Welcome back. In this video, we're going to talk about how to manipulate data in R. So here we are again in our RStudio layout, and you can see here I've got my R Markdown open, and I've also got an R script open with today's code. I'll be sharing both of these along with this video. So in today's presentation, what I want to go over is how to add new vectors to your data sets, talk about the difference between numerical and character values within data sets. We're going to briefly touch on how to do for loops in R, how to do data transformations, binning data, and then we're going to use a package called maps to plot points on a map. And then finally, we'll split data sets into quantiles. All right, so the first thing that we did last time is we went to Session, Set Working Directory, and Choose Directory to go ahead and set our working directory. And then we copied that from the console over to our script. My cat is very needy right now, but I think he'll manage just fine. You'll notice that I've used this panel to sort of drag this over here, and I've dragged this way, and then that way I can kind of maximize this screen here. The next thing that we're going to do is we're going to read in our data just like we did last time. So we're going to be working with this uspop.csv that we worked with in last video. And you can see that I pressed Control Enter or Command Enter to get it to launch to my console. It popped over here, and then immediately I have data in my global environment, just like we did before. Now what I'm going to do is I'm going to add a new vector to this. So if I click this over here, or I can type view data, and you can see it automatically launch that. I have two columns in this data. I have year, and then I have population, okay? And what I may want to do is calculate what the midpoint of the data points are. So here what I'm going to do is I'm going to make a new column called midpoint. So this does not exist yet. And what I'm going to do is I'm going to add 5 to the year column to create this. So you can see I have years ending in 0, so this is going to give me the midpoint between each of these. Okay, so let's go ahead and execute that, and then we'll view our data again. And you can see now we've made a new column, and this column is 5 more than what was in the year column. So 1795 is the midpoint between 1800 and 1790. So the next thing that we want to do is look at something like growth. So we might want to look at what is the difference between the population at this time point versus the population at this time point. So in order to do this, we need to actually loop through our data and then calculate a new vector called growth. We're going to do a couple of steps here. So first, we're going to create a vector. We're going to name that vector using the command vector, and then we have a couple of options in here. So we're going to do mode equals numeric because we're going to store numbers in there. And then we're going to say the length of this is data $year. But we could also put data $pop. It's basically just 23 observations, the same as the rest of it. So let's go ahead and initialize that vector. And you can see over here, I have a vector here, and it's numerical. It goes from 1 to 23, and right now all of the values are initialized at 0. Now, in our case, if we want to go through this and we want to say, okay, I want to subtract this from this to figure out what the growth was, then the very first value would have 0 growth. So let's go ahead and set the very first value at missing, right? And then we'll set up a for loop. So just like we've done in Shell and in Perl and in Python, we're going to say for I in, and then we're going to say, where do we want to start and where do we want to go? By default in R, it's going to increment by 1. So we're going to start at 2 because we've already defined the 1. And then we're going to go to, again, that same length of data vector. So if I click run this, and then I can do this. I'm just highlighting part of the code and running it, and you'll see I return 23. So this is the same as 23. Okay. Then what do we want to do in our loop? What's our loop body? So we're going to say growth I. So this is an array. A vector and an array are very similar to one another. So here what we're saying is the ith element of growth should be equal to the population size at time point I minus the population size at time point I minus 1. And then we're going to add 1 to it. So let's play around and see how this loop is behaving. So let's do I equals 4 on our console here so that we can initialize I. And then we're just going to run this line inside the loop, and then we can press growth I, and we'll see this is our growth, okay? This is the same, so we said I was 4, so 1, 2, 3, 4, so that should be the same. Remember, we can just do math on the command line console here. Oh, yep, exactly. And we're adding 1 to it, right, in our thing, because when you take the difference between two numbers and then add 1 to it, that's going to tell us how much growth has occurred, okay? All right, so now let's do that. We're going to initialize our vector because I messed with it. I now assigned a number inside of there, so let's just go ahead and initialize it again, and we'll make that first value in A, and we'll run our loop. Now you can see that we have this thing here. We can actually type it here. And that's what growth looks like. And then what we can also do is do cbind, which is another way to, it's a column bind between data and growth. And then we can rename that in the object data. So we're adding a column to it, very similar to how we did that here. We're going to add it here. Okay, and if we go back to our data, you can see we now have a column for growth. Now we're going to want to explore this new parameter within our data set, growth, graphically. So let's look at the histogram of growth. And that's going to produce over here, and I can drag this so that we can see it. Now we can see our histogram of growth over here. I'm going to move this up a little, and you can see that there's a nice distribution of growth throughout our data set. Now we can take the log transform of growth and plot that, and that looks a little bit more like a bell curve or normal data like what we're used to. It's not perfectly normal, and there's statistical tests that you can look at to see if your data is normally distributed, but you can look at this and tell it's very much not normally distributed. Whereas this log transform of our data, which is one way to transform data, is normally distributed. And since vectors work such that if I apply a function to a vector, it applies it to every single value of that vector, this is a really great way to apply some sort of transform. And we did the same thing that we did before with midpoint, where we're adding a new column to the data set. So let's go ahead and look at that here, and you can see that it didn't take the log of this value because it's in A, and it did all the others. All right, so now what we want to do is compare this. This is the plot that we did in our previous video. Remember when we were plotting the population, or the dates against the population size? Now what we can do is do the same thing, but do it with our new growth column, okay? So now instead of plotting the population size, we're plotting the change in population over time so that we can sort of see that, you know, we've got up and down and up and down. Now we can plot the log transform of that, and we can see that it's a little bit more of a linear relationship. And then, like we did in our previous video, we can go ahead and do a statistical test for a correlation between year and growth. So let's first do the Spearman rank correlation test with between year and growth. You can see that we have a highly significant p-value and a rho value that's close to 1, suggesting that they're statistically significantly correlated. Similarly, we can do the same exact thing, but with our log transform, and you'll see that when we do the correlation test with the raw data versus the log transform data, there's no difference in our correlation results. So now we're going to examine a built-in data set in R, just like the Anscombe's quartet that we used in our last video. We're going to use the built-in data set called Quakes, and I just printed Quakes to the screen, and you can see that. Let's look at this data set. It's 5 columns here. We've got latitude, longitude, depth, magnitude, and the station that reported. So this is an earthquake data set, and in order to examine this data, we're going to be using the package MAPS. So I want you to go ahead and install the package. The way that you install the package is you click Packages and Install, and then you would just type Maps, and you would click that. Now I'm not going to install this because I already have it installed. So the other thing that you'll want to do is run Library and then Maps, and what that's going to do is load it into our current session of R. Okay, and you can actually also load it by clicking the Maps button over here, and so you can see I've got a lot of packages, and you can see it's now checked. I can unload it, it's called detach, or I can load it back. Okay. All right, now what I want to do is explore this quakes data set. Now for me, I'm really interested in the magnitude of the earthquakes, which is this MAG column. So let's go ahead and get a summary of MAG. And so if you're familiar with earthquakes, or you're from a place that has earthquakes, you might remember that earthquakes can typically range from 0 to 10, with high intensity earthquakes reported on the news, somewhere between 6 and 9. And so here you can see that this data set has a minimum of 4, and it's very hard to get something under a 4 to register. And then the mean earthquake is 4.62, and the max in this data set is 6.4. We can also look at quantiles of our data. So this is splitting it up into literally quantiles, and that means that a quarter of your data is in each of these bins. This is a way of binning data, and you can see that the average of each of these quantiles is 4, 4.3, 4.6, 4.9, and 6.4. Okay. The next thing that we can do is we can add a new column called quantiles, and we can use the command cut. What this does is it's breaking our data up into these bins based on the quantiles. So what we can do is say the magnitude is the column that we want to cut on, and we want the breaks to be the quantiles in that. And then we want to make the labels equals to false, and then including the lowest, i.e. this number, equals to true. So let's run this, and then look at our quakes data over here. So you can see it's just that built-in data set with those 5 columns, and then we've added a column here to say which of the 4 quantiles is this magnitude of earthquake in. So you can see this is 4.2, which is on the low end, and this is 5.4, which is on the high end. So it's in quantile 4, and this is in quantile 1. Okay. The next thing that we can do is we can add a color label to that. So here we've added numerical label. We've said labels equals false, so it automatically labels it 1, 2, 3, 4 based on the categories. Here what we're going to do is we're going to actually add labels, and we're going to use this C thing to make a character set, and we're going to do 4 because again we have 4, and we want the lowest to be gray, and then we're going to use color to indicate the intensity, with red being the highest and yellow being the lowest and orange in between. All other parameters are exactly the same as our previous one, except we're going to name the vector something different, and we're going to say color. And then we want this to be treated as a character. So let's run that and then look at our quakes data again. And you can see now we have this color column added, where anything that had a 4 in this column also has a red in this column. 1s are gray, 3s are orange, and then 2s are yellow. So why are we doing this? What is the point of this? Well, the point is that we want to plot these on a map based on the intensity, and we'll be able to use these quantile columns to do that. But first, before we map it, let's look at the range of latitude and longitude that we have in our data set. So our latitudes range from -38 to -10, and our longitudes range from 165 to 188. So that's actually a pretty tight margin. So let's go ahead and do a map of the world. We'll just do a default map like that, and you can see I get a map of the world. What we can do is we can use this argument xlim for x limit and ylim for y limit to take the values. Let me copy this. So this is going to take the minimum and maximum values of our latitude and longitude coordinates. So the x-axis is going to be the longitude, and the y-axis is going to be the latitude. So this is going to change the coordinates. We've sort of zoomed in. Now, this is a little too zoomed in, which is why you can see that in my code, I've sort of zoomed out. So we've taken these longitude coordinates, which you can see go from 165 to 188, and we've subtracted 30 from them. And then the latitude coordinates, we've subtracted only 15 from. Let's zoom out and see what that looks like. Okay, so now we're starting to see something here. And we could zoom out even further, right? We could do 45 and 45, and then make this one 25 and 25. Now we're starting to see something. So before we were here, I couldn't really tell where we were. Kind of saw New Zealand, but now we know for sure we're dealing, there's Australia, right? Okay, now we want to add our data points. So we're going to use the function points, and that's going to add the latitude. Again, remember longitude is x and latitude is y. And then we're going to use this point character expression, and we're going to do 19. Remember last time we did 11. All right, so that is a lot of points. Maybe we should zoom in so that we can see them a little bit better. So let's go ahead and do that. And actually, I'm going to leave those there because I have adjusted them again here. So now what we're going to do is we're going to add color to the points using this call thing. And instead of typing out the colors, we can use that color column that we made that color codes them based on their quantile. So let's go ahead and do that. Wow, okay, so now you can see that there's a variety of different earthquakes. They're not all black. They've got gray, yellow, orange, and red based on their intensity. Now, the other thing that you might be interested in doing is not only color coding them according to their intensity, but maybe changing the size of the points based on their intensity. So we can blank out our map like that. And now what we're going to do is we're going to go back to that points command. We've got x and y, we've got our colors, we've got our PCH equals 19, and now we're going to add this argument here. So this character expansion argument, or CEX, says let's make it 50% of whatever the number is in the quantile column. So remember, this is numerical data from 1 to 4 based on the intensity or the quantile that it's in. And then if we multiply that by 0.5, such that 1 would actually be 0.5, 2 would be 1, 3 would be 1.5, and 4 would be 2, twice as large, this would allow us to see the points in different sizes. And there you can see that it does that. Let's go ahead and press this button. What I like about this is it sort of makes this larger, and you can actually make it full screen. It takes a little while to replot, and with the Maps app, you're going to get a lot of weird white space, which you can usually trim out once you get it out. But you can see I've got these nice little gray dots, then the yellow, then the orange, and the red are the largest. So it's color coding them and plotting them their size based on the intensity of these. Now, that might be a little bit too much, so what we can do is we can replot it using the character expansion at 0.25. Sometimes it gives you an error that it's too large. So let's make it a little bit bigger. There we go. And you can see that this is nicer because they're not all, so large that they're obfuscating the map itself. Okay. Come on. I want to make you smaller. There we go. All right. So hopefully I have covered a variety of things in this video, and I'll just go back to my intro. We've covered adding new vectors to data sets, numerical and character values, for loops, transformations, binning data. We've used the Map app, and we've split data into quantiles. All right, enjoy.